Welcome back, Algebra 3 students. Today we're going to be looking at reflections of parent functions. You should have your notes packet, and you should be on the page that says Reflections of Parent Functions, Part 1. The first part of the page looks like what is listed below. The very first thing you're going to do in these notes is always add the parent function. And so let's take a look at the first graph. We have to figure out what its parent function is. So right there is our first clue. That has the square root, so we know that that is not the square root, I keep saying that. That is the squared, so we know the parent function will look something like this with our critical points. Okay, again, my drawings on these screens not so good. Okay, I'm going to come over here and change the color. All right, let's take a look at this one. We have this square root function, so we know the parent function had a starting point there, critical points at 1, 1, 4, 2, and 9, 3, and I call this one the swoosh, and we fill in the swoosh. And the last but not least, we have our absolute parent function, our absolute value, and that one is our v. And we know that our parent function looks something like this. It kind of looks more like a U, but it is a V. Okay, in your notes, make sure that you have all three of these parent functions labeled. All right, so your notes at this point should look like this. However, these are just the parent functions, and our new functions, they don't have just the parent functions. They now have negative signs out front. So we have a situation where we have three of these parent functions that now have a negative sign on the outside of the grouping symbol, meaning the negative is not inside the square root, inside the absolute value, or inside the square. So what does that mean for our graph? Well, I want everybody to head to Desmos, okay, and we'll find out what that means for our graph. Okay, what I would like you to do at this point is to pause this video and go to Desmos, desmos.com. You can do the /calculator, or you can just hit desmos.com. And I want you to plug in or type in those three new functions with the negative signs. And I want you to write out what happens to your parent function. How does it move? Where does it go when you put a negative sign? Make sure you label those critical points, and then restart this video and see if you get the answers correct. Okay, welcome back. I hope that you were successful and you saw some interesting things. So here's what your notes should look like. When you put the negative in front of that x squared for the quadratic function, you now have a upside down parabola. Those critical points are still the same, okay, but it has a new characteristic. It's not pointing up anymore, it's pointing down. And take a look at what happens to the square root function. It also has the same critical points, except for now instead of going over 1, up 1, you're going over 1, down 1, or over 4, but now you're going down 2. All right, and then let's take a look at what happened to the absolute value. The absolute value right here is the same. It's just like that parabola earlier, but now that V is pointed down. So make sure that your notes look like this. And I want you to think about a conclusion statement for this. What happens if the negative sign is on the outside of the grouping symbol? What does it make the function do? Now that you've had a chance to think about it, let's talk about this conclusion. Well, here is our graph, and what I really want you to think about is reflections. That's the title of today's notes. And so if that's our mirror or our line of reflection, it's been reflected over the x-axis. There's the x-axis. Okay, and so we now have a reflection. We have a way to reflect these parent functions. So conclusion, if a negative sign is on the outside of the parent function, then the parent function is reflected over that x-axis. Let's think about what happened to domain and range. Okay, so domain for the reflected quadratic, it's still all real numbers. Remember, domain tells me what values of x I can plug in. I can still plug in negative 100 or a positive 1000x, and I'll get an answer. So sometimes you'll see it written with two lines like this with a big capital R. That domain is still all real numbers. Okay, but now the range, which describes the y values, we're never going to get a positive y value. So we're going to be going from y goes from negative infinity. Let's see if I can draw a nice infinity symbol here. Not so good. Okay, y's, all of our y values are in between negative infinity and 0. That's an infinite sign. So we never go above that line with our range. Take a minute, and I want you to think about what's the domain and range for the other two reflected graphs. Can you write the domain and range for the square root function? Try it. All right, at this point you should be on part 2 of your notes, and so now you need to draw in each parent function and then labeled with its critical points. Notice this time we're starting with the square root function, then going to the absolute value function, and then finishing with the quadratic. At this point, please stop the video and again go to Desmos. And this time when you type in these functions, notice where the negative sign is. The negative signs are right now on the inside of the grouping symbol. We're now on the inside of the square root. We're on the inside of the absolute value, and we're on the inside of the square. So take a look to see what you think is going to happen. Type it in, y equals the square root of negative x. Look at what Desmos gives you, and then draw in that new function with critical points labeled. Okay, welcome back. We're going to talk about the first graph, which was the square root function. So what happened when we had the square root of negative x? Well, let's take a look at this. Notice here, I still have the same starting point at 0, 0, but now my next critical point, that was at negative 1, 1, negative 4, 2, and then negative 9, 3 was over here. So my new graph looks like this, guys. Very odd. Think about what just happened in the first part of our investigation compared to what happened here. I'm going to draw this here and label this as our y-axis. Okay. Please make sure you have the other two graphs finished and that you are going to write the conclusion for this. But this is what we'll talk about in class. So make sure you have the other two graphs labeled with the new function and its critical points. All right, Algebra 3, it's your turn to write a conclusion. If you're having a hard time writing a conclusion, maybe think of answering these questions. What happens when a negative sign is on the inside of a parent function? Explain that to me. Or if you like it worded a different way, how does a negative sign on the inside change the graph? Good luck, and when you come back to class, we'll discuss your answers to these questions. Have a great day, Algebra 3.